But first of all, let's meet. Werner, who are you?
Yeah, I'm currently the member of the Jakarta EE Specification Committee. I'm also project lead of a couple of JSRs, including money and units of measurement. And I'm one of the committers of the Jakarta NoSQL project and the reference implementation. And beside that, I also help clients with all sorts of projects around the JVM. Right now, it's a little more on the front end, but that also has a lot of backend systems and databases that, in this case, are a little more traditional, but some of them use NoSQL databases. And I think we also have some prototypes running there.
Cool, quite an intro. So just a word about myself as well. Full name is Theodoris Bais, or Theodoris Bais. In English, originally made in Greece, living and working in the Netherlands for the last 5 years. You can just call me Theo, as Selma did just now. I have the honor to be the founder and leader of the Utrecht Java user group. Besides, I'm working as a Scrum Master at the ABN AMRO Bank. And of course, at my free time, I help others achieve their goals via my own company, Agile Leaders. Speaking of ABN AMRO, I only have one marketing slide for tonight. Of course, we are always on the lookout for great talent. So feel free to have a look at our website should you be interested or also on the lookout for some new challenges, or just get in touch with me after this event to discuss any potential opportunities. Now, what a year has that been, right? I read somewhere on the internet the other day that it's been 12 months that we are still in March 2020. However, I'm pretty grateful that we are able to even keep running our events and keep having those kind of events to keep sharing knowledge. So let's start the other way around. What are the 5 main trends in 2021? And this is also the way to start unveiling our talk for today. So one of the main trends in 2021 is that more customers are going online. Second of all, the internet is nowadays connecting everything. Third trend, big data is getting bigger and bigger and bigger. The fourth trend for this year is that many apps are moving to the cloud. And last but not least, our world has gone mobile. This is a fact. And what does this mean? I'm pretty sure most of you are already wondering, why have we started unveiling this talk like that? Because new digital trends create new technical challenges. And that's why we're here today as well. So, what are those challenges? Let's try to have a quick look at each one of them. Of course, nowadays, I also work as a Scrum Master, but I'm pretty sure you always get those crazy requests from your product owners, your engineering management, and so on and so forth. Crazy requests about developing faster, being more agile. Oh, sorry. I don't know how I did this, but apparently we'll learn something today. Let's go back to the challenges slide. Agile development process. Second challenge is high performance and availability. And of course, managing huge data volumes is one of the most biggest challenges today. Don't worry, NoSQL is here for the win and to also come to our rescue. So NoSQL stands for not only SQL, and let's double click a bit on the advantages it comes with. First of all, with NoSQL, we can always handle large data volumes at high speed. We can store unstructured, semi-structured, or even structured data. Third advantage is that it enables us to perform easy updates on schemas and fields. It is developer-friendly, and one of my favorite ones, it takes advantage of the cloud to deliver zero downtime. Okay, cool. So we started with the 5 trends of 2021. How or what are those challenges that are being created through new digital trends that NoSQL comes to the rescue? What are the advantages? But here's the catch for today. Why this talk? Why are we here today? Werner connecting from Germany, me connecting from the Netherlands. Why are we spending our evening today together? Of course, the JVM can cope with heavy loads. However, there is a bunch of persistence frameworks available out there. So the question becomes, which one performs best for your case? Something that would normally take ages to compare. So we did that for you, and that's why we are here today. Again, what is NoSQL? Because we only touched a bit upon its main advantages, right? So it mainly has to do with a database that doesn't use any semi or structure, same structure or even structure. We don't have the commonly said transactions concept as we are used to with SQL databases. It is based on the base concept, which Werner will tell you more about in a couple of minutes, and it has 4 different types. Which are those 4 types? Werner, over to you.
So there are multiple types. The first one would be a key value store, which is essentially.
If you're sharing, yeah, it's there. Yeah. Great, cool.
Yes, can you see it? Yeah.
Yeah.
So the first type would be key value stores with systems like Redis, Hazelcast, or also some that are available in the cloud by Amazon. It's more or less like a distributed map. Okay. Somehow the clicker doesn't work. Yep. Now it works. So the other one would be column oriented, which is a little closer to the traditional SQL databases with rows and columns. Examples are Cassandra, DynamoDB, HBase, or several others. Then we have document stores like Couchbase, CouchDB, or MongoDB. And we have graph databases, which often allow even more sophisticated relationships between the nodes in these graphs. Neo4j is probably the most popular solution, as well as others. And then there are, if you want, like the shapeshifters that are multimodal and that support more than one type, sometimes even in the same database. So you got OrientDB, which can support both graph and document, Couchbase, ArangoDB, even has up to 3 different types that can be combined. So what are the most important terms? And depending on the system, these can vary. Some of them are pretty common, others only apply to, for example, the graph database, like an edge or a vertex is something that you probably won't see in any of the other systems. That just wouldn't make sense. We have base versus acid, as already mentioned. So acid stands for atomicity, consistency, isolation, and durability, which applies mostly to traditional SQL systems, as opposed to base, which stands for basically available, soft state, and eventual consistency, which is more a concept that applies to NoSQL databases. Then there's also diagram about CAP, consistency, availability, and partition tolerance, which you will see that some of the traditional SQL systems, they're more on the upper left-hand side, while others like MongoDB and Redis are more on the right-hand side, and systems like Cassandra or RIAC in the bottom. And that is another way to look at the possible alternatives and see which one applies best to your application. And then you also have scalability versus complexity, with key value systems being quite scalable. And on the bottom, you have graph systems, which are naturally more complex because of their different relationships that you can have between the nodes and queries that you wouldn't have in others. So in an application, you usually have a data access object layer that your application speaks with. That is pretty much in common between both of them. And with the traditional relational system, you would normally have something like JPA, and then underneath the JDBC layer and the actual database. With NoSQL, that is often very different and fractured because you may end up with 3 different APIs for 3 different types of databases, which is of course not so good if you want to combine them or change from one to the other. And it also means some additional learning curve if you have one project that works best with a graph database, and then your team needs to start working with a document-based solution. That can be a problem and mean some additional burden. So we compared some of the most popular persistence frameworks that are available for either SQL and NoSQL, or some of them are more specific to SQL, but most of them also offer a NoSQL alternative. And we are looking at, for the sake of showing them more easily, only Neo4j and MongoDB, but all the demos that you can run from the repository yourself also offer access to multiple other databases, especially on the JNoSQL side. There are many systems it supports. So JPA has a lot of issues when you try to apply it to NoSQL databases. Here are some of the more common ones, and obviously the diversity is also a problem when you need to combine them or switch between them. So let's look at what most of these solutions, except a few, have in common, which is annotating entities pretty familiar to what you may already know when you use JPA. You can use the template approach, which especially Spring Data made very popular. And Spring in particular also uses those kinds of templates. For example, when you deal with GMS and other parts, the Spring framework has several kinds of templates, not only for databases and Spring Data, but that's something that Spring Data also applied. And the second approach is to use the so-called repository pattern from domain-driven design and use a repository that is specific to, for example, here MongoDB. Here's another example with additional properties. And you see that it's quite easy to switch from one to the other. Basically, all you have to change is the database type. Repositories can also support queries. So that's a little bit like stored procedures in JPA for doing more sophisticated things. And you can have additional annotations that often only make sense for a particular system. So here is an example for Cassandra, but there are also a few with graph-based systems that allow to apply additional queries that only make sense in this particular context. Query by text. Here we also have the graph example, again, where you can apply queries in a very sophisticated way. Now let's look at a few examples. We saw NoSQL and Jakarta NoSQL, but there are also others with a tiny caveat, because there's Micronaut Data, but at the moment it only supports traditional relational SQL systems. So what about NoSQL? Well, the good news is Micronaut does, but at the moment you're still a little more bound to the underlying specific and often proprietary APIs. So if you want to switch from one to the other, there may be more changes required to your code. Here are some examples. So it also applies the repository pattern, but here without annotations. So it's basically just you define a class. The same with the entity. So while it uses common Java and Jakarta EE systems underneath the hood, especially dependency injection, but here at the moment it does not apply annotations yet. So this is one of the cases where you don't need annotations, at least not until maybe Micronaut Data may change that. And you can also have a query by text, similar to what we saw with NoSQL. Another example that is especially popular in the Groovy and Grails community is called GORM. And again, GORM does not so specifically put a layer and an abstraction between the different systems, but it has entities that are annotated, which is also why Micronaut Data, being heavily inspired by GORM on the JPA side, may well end up with some more of these annotations and other mechanisms that you can already use in GORM. Okay, so let's look at an example before Theo takes over again. So first of all, the Jakarta NoSQL and JNoSQL demos. I hope is the font size okay? Okay, I don't hear anything, but I guess
Yeah, Werner,
there's no.
looks good. Looks good.
Yeah. Okay. Great. So first of all, we have Hazelcast, which is key value based, and we use the repository pattern. So here we have a user repository, and then we look for a user and show the result. Doing the same with a template, it's not much different. So again, we have a key value template here, and the rest looks pretty familiar. Now, if we switch over from key value to a document-based systems, this is how the same looks with MongoDB. Again, that's the repository approach. And next to it, there's a template-based approach. And here you find a few aspects that the other templates and also the other repository wouldn't have. And that's, for example, traversing the vertex, because that's basically something that is specific to a graph-based system or to Neo4j. So you would find it maybe between multiple graph-based systems, but you would not find that, and it also wouldn't make sense in most of the others. So let's run a couple of those. Most of them actually run standalone, especially Hazelcast runs in memory. So it may take a few moments to instantiate everything, but you don't need to install anything separately. Now let's wait for the black text. Yeah, you actually see some internals already, and here we got the result. In this case, it's a small prototype of a user database. And doing the same with the template. There we go. Now let's look at an example for MongoDB. Those usually do require a separate MongoDB system under the hood. So you need to have at least a local MongoDB installed. And here we have an example with gods and their various powers and attributes. And yeah, so with Neo4j, you actually have two different options. Let's try the first one with a standalone. So basically this means the standalone does not require a separate installation. Just see. Oh, sorry, I think that's actually the one that does, because here you see the port and you see the gods, and let's have a look how these look like in the Neo4j database in the browser. So here we get the gods that have been stored in this Neo4j system and also their relationships. So we have Odin, who's the father of Thor. And if we sort of drag these little, yeah, so he's the grandfather of Magni, who is the son of Thor. But Thor also has a stepson called Ulre, and therefore Ulre and Magni are related to each other in both ways via being a stepbrother of the other. And we can also run one more example. I think we are not so bad in time. So thanks to Apache Tinkerbell, which has a sort of layer in between, allowing you to mock away certain graph systems, you can actually run most of the JNoSQL demos also through Tinkerbell, and then you don't need a separate standalone Neo4j system. This also works for most of the other supported graph databases. So here we have a travel application with cities and travelers. So let's look at the cities that are around. And the travelers, which are also related to each other here. And we can probably see if we run this travel app in the embedded mode. Yeah, so I can really show you by switching off Neo4j, you would see that this one is independent, and that's also why it's not necessarily really faster, because here you need to actually build up the database first in memory. Yeah, so it takes a little while, but here you also see the same results, and that one does not require a separate independent installation of Neo4j. So either if you want to test or do some rapid prototyping, this may of course be quite an advantage. Since this goes through Tinkerpop, at the moment this is not available the same way for most of the document-based systems. So for MongoDB, you would need your own dedicated MongoDB installation on your local system or in the cloud. But thanks to Tinkerpop, for most of the graph-based systems, you can choose whether you use the embedded mode like this, or you use a dedicated standalone database next to it. And last but not least, I set this up because it may take a while. This one shows us GORM, and it also combines GORM and Micronaut, because both of them are running on top of each other. So this one is GORM inside Micronaut. You can also use the Micronaut APIs directly inside Micronaut. At the moment, you don't have Micronaut data for NoSQL yet, but you can use the dedicated APIs if you want and if you prefer. But especially in Micronaut, you also have the option to use GORM instead of the Micronaut built-in systems, so you can have the best of both if you want. Now let's look at this one. Yeah, so here we have two users. That's a new Postman. It's a new UI, but it seems to be a little slow. Yeah, here we have one dedicated user. Okay, let's not create a new user, but let's try to update that one. Okay, somehow the new version of Postman definitely a little slow. Don't start to force people to always connect to their own cloud, because there are some others that go that way, that you can even use them in a custom-based system, because it will always force you to send data back into the cloud. Come on. Okay, so the update looks successful, and let's just try the list of all users again. And voila, Monsieur Tessier now got a new password. So the update was a little slow, but it was successful. And with that, I would hand over to Theo again.
Yeah, Werner, thank you.
Do I need to unshare, or can you just share your screen?
I think I can just take over, but before taking over, are there any questions so far? If not, I will take that as a no. But again, feel free to interrupt us at any moment.
I believe there's even a dedicated Q&A later. Should there be more questions afterwards?
Okay, that's always cool. So let me take over. Let me start sharing my screen again to see what bits and pieces are yet to be explained. So I would like us to double click on Spring framework for the rest couple of minutes. And let's start with MongoDB. I would like us to do this part, this very last part of this presentation, to actually split it in two different parts, the logistics and the domain part. So we're going to see the Spring Data MongoDB framework. And let's start with the logistics. In logistics, we will have nothing else than the most simple dependency, which is the Spring Boot Starter Data MongoDB that you need to add to your POM XML file. Next to that, you just need to configure two properties. The database name, in this case, as Werner showed, mythology. We're going to see some Greek gods, guess why, and of course the port. Now, that's all about it. No rocket science about the logistics part. Let's have a quick look at the domain. Everything is a document. Every Pojo class in your MongoDB, in your Spring Data MongoDB, has to be annotated with the @document, and of course within the collection, within the parentheses, you have to point it to the actual collection of your database. That would be all about the model. And again, as Werner showed, for other types of persistence, we here have in our repository the same way we define our repositories in our beloved Java way of repositories. Again, a very small caveat here I would like us to double click a bit on is that we always have to extend from the framework specific repository, which in this case is of course the Mongo repository. So for the model or for the domain, @document on top of the class. Then for the repository, we need to extend from the framework specific repository, in this case, Mongo repository. And what happens with the controller? Now, let me also keep a secret for the next couple of minutes and we'll see together. That is all. That would be all about it for the Spring Data MongoDB. Now, next up is, of course, the Spring Data Neo4j. And our example, in this case, I will do both. I will explain both in the slides for MongoDB and for Neo4j. And we will then have the chance to have a quick look at some code and the demo, of course, as Werner just did. Neo4j comes by default with a movies database. So in our example, our graph would look like this. We will basically have two entities, person and movie, and of course, one of the most famous actors for this example, Tom Hanks. He played, so he acted in, this is a role. We will see in the next slide how we can define a role. And this is a movie. So two entities, person and movie, a relationship between the two entities. The person entity acted in the movie entity, or a person directed a specific movie. So there needs to be some magic in there in the way we need to define it. You know the drill, logistics and domain. Let's start with the logistics for configuring Neo4j in Spring Data. Here we have the Spring Data Neo4j RX Spring Boot Starter, because of course working with Spring Boot is the easiest way to demo things nowadays. However, a very small note here, a very quick note. We used the RX dependency because that way it is easier to manage and to have to manage the dependencies, to have the entities updating one another back and forth through the controller, and of course it is the suggested way for reactive programming. Same way, we have to define a URI for our database. Of course, everything runs under the boot driver in this case, and just a username and a password for connecting to our database. Now, what about the domain? As we said, we definitely have two entities in this case, the person entity and the movie entity. However, for the movie entity, for example, we need to have a repository. And for the person entity, you see how it goes. Why is that? Because the roles play a big role there as well. So here we will have, again, two entities and only one repository, the movie repository. No person repository. We will define anything in between person and entity using some relationship properties. And what am I talking about? Please keep this keyword, relationship properties, in mind for the next slide. Let's double click now at the repository. That goes the same way we are already used, or we have already seen for the Spring Data MongoDB. Our repository needs to extend from the framework specific repository. In this case, reactive Neo4j repository. And of course, some reactive methods, repository methods, in this case, a mono entity, a mono method for the movie entity. And let's have a quick look at the entities now. Remember what we said? Person entity, movie entity. That's it. So every entity has to be annotated, in this case, with an @node annotation. as we do here, add node person for the person entity and add node movie entity. No rocket science involved in our person entity because it is the least complex. Here you can still have a look at the schematic for our graph database or for our graph schematic. And what about the movie entity? IDs, okay, cool, some property on the description. Remember when I said relationship properties? We start defining the relationships by annotating our movie entity with the at relationship annotation, with a type of acted in and a direction incoming, as we've seen here in the graph. Same goes, more or less, for the other relationship, the directed relationship, which should be of a type directed and of a direction incoming. However, we're not done yet, are we? We still need one more class to actually define those, or to actually connect those two entities with one another. In this case, that class can be our class named as roles and tagged with the annotation relationship properties. Now, enough about the theoretical part. Let's have a quick look at some code. What are we gonna do? Again, we used Spring Boot for both demos, both for the MongoDB demo, the Spring Data MongoDB demo, and for the Spring Data Neo4j. Both of them are already started. We've already seen the JNoSQL and the Micronaut demos. So let's together try to unfold the example for the Spring Data MongoDB, starting, of course, from our beloved model. We've seen most of the code already, nothing crazy to mention as such. The repository, we've seen it in the slides as well, but I still promised something, didn't I? I promised about showing the magic the controller comes with. So let's have a quick look at the controller. Okay, what do we see here? A cross-origin.
To increase the font size a little bit? Does that also work in?
Yes, I can do this. Please let me know if it is getting updated.
Yeah, I'm not sure about the others, but at least it looks a little small.
Is it any better? Because I see here in the screen it is not getting updated. I am trying to increase it. Otherwise, if it is not visible, I would say, please, or either come closer or we will share the code in the repository.
No, I think it's okay. The view here is also slightly smaller, but if you're close to 100%, I believe it's okay now.
Okay, cool. So what do we see here? A cross-origin annotation, a REST controller, a request mapping, of course, as we are used to with our beloved REST API controllers, the Java way. And where is the framework-specific code? I cannot see it, can you? That's it. There is no framework-specific code for our controller. Everything has to be defined or the way we are already used to define our API or our REST API controllers the Java way. So that's the magic of this Spring Data MongoDB framework. No additional code for our REST controllers. Again, the only thing we need to do is annotate our domain classes with at document parentheses collection equals pointing to the specific collection, and the repository we need to extend from the framework specific repository. Now, just for the sake of having some demo, I will just try to fetch from a pre-filled database all the gods. So here is a quick get request from our dummy database. Let's say I then want to fetch all gods containing or starting whose name starts with these 3 letters. Here, I only have Ira, right? So let me try to actually add one more, Hercules, the god of strength, right? So I will add Hercules here. Let's go back to our initial request. I should be able to see one more object here below Sally, which is the case, Hercules, which actually implies that our get all gods by name containing request should return 2 objects. Now, I will follow Werner's lead. I will not try to run all the requests for the sake of time. Let's try to delete, though, one simple object, one very dummy object. As you can see, the one ending with 1b9 is Salido, which has nothing to do as an object in this database, in this dummy database. So again, get all gods returns no Salido. Okay, that would be all about the Spring Data MongoDB. So let's have a quick look at the Spring Data Neo4j examples as well. API and domain we have here, as we've seen, the movie entity, we've seen it in the slides, the movie repository, the person entity, again, node annotations, and the roles, relationship properties as an annotation, and that will be all about it. Again, the controller, no magic involved at all. Feel free to develop or to create your controller the way you're used to already from your REST API controllers. We have a creator update movie, some put mappings, of course, the get movies, get movie by title, and of course, deleting by ID, which does nothing else other than querying our repository accordingly, our movie repository accordingly. So, quick demo here as well, but before going to the demo, I always like the way Werner shows Neo4j on the screen. So here's a quick look to our graph database, to our movies graph database, the default graph database Neo4j comes with. And here we are just focusing for this particular example on Tom Hanks. He acted in Castaway, in Cloud Atlas, and so on and so forth. On the other hand, John Patrick Stanley directed a movie Tom Hanks has acted in. You can play around, of course, with the browser instance of your Neo4j database. It's always fun to play around with such things. You have no risk. You're running no risk deleting anything. So let me just, for the sake of fun, run the get all movies query. We should expect to see a couple of pre-filled movies. As you can see, quite some data, quite some movies. And suppose I want to get a movie by title, as we've seen in our movie controller. In this case, I'm interested in the matrix. So I'm querying by title with title equals the matrix. As you can see, our object is quite rich, as in properties, directors. There are two directors here. There are also some actors and roles, as we've seen, some title and some description. Now, approaching the end, let's just delete the very last movie in this sequence of movies. It is a delete request as defined in our controller with our beloved a delete mapping request as defined in our controller with our beloved mono entities in this time. So let's quickly delete this movie. And that should give us a result up until the Polar Express movie, which is the case. Okay, looking at the time, I feel we already had some time and chances to begin with our comparisons for today. We started with the 5 main trends of 2021. We unveiled it with NoSQL databases, their advantages, how they can come to our rescue, and how they can best serve our needs for big data and the challenges we are asked to solve as engineers nowadays. We compared, or we showed, the most prevalent Java persistence framework and how those compare to NoSQL databases. But I'm pretty sure many of you are already wondering, and with that I'm changing back to the presentation. I'm pretty sure many of you are already wondering, what happened with Hibernate OGM? Let's have a quick look at this one as well. How would we define an entity here? Annotation entity, one-to-many generic generators. I already start getting sick, so let's have a quick look at the next slide. Transaction managers. I can make it even worse. So there is a warning, as you can see from the documentation. In most cases, multi-document transaction incurs a greater performance cost over single document writes. And of course, the availability of multi-document transactions, but that should not be a replacement for effective schema design. You can read the rest afterwards as well, or even in the documentation, but this is a hint for our conclusions as well. And with that, I would like to directly jump into the conclusions. What about the JNoSQL? Werner has shown some very good examples, some very nice examples. However, there is a catch here. It is still a work in progress. On the positive side, it does remove much boilerplate code and provides a cleaner and more readable DAO. It supports a huge number of NoSQL database systems, as we've seen in the demos. And of course, its loosely coupled code makes switching between different NoSQL vendors just a matter of configuration, just a matter of the logistics, as we've seen. That will be all about it for our conclusions on JNoSQL. What about Micronaut? Same goes here, same goes for Micronaut. It is still a work in progress. Also, switching between different NoSQL vendors is not so easy. One more disadvantage I would say here is that Micronaut Data does not support NoSQL databases yet. So what we've seen with Spring Data is not the case for Micronaut Data. The data persistence framework, specific framework of the actual framework. On the positive side, it is often faster and has a lower footprint and polyglot language support for Java, Kotlin, and Groovy. Now, a very quick conclusion, or a quick list of conclusions for GORM, the Groovy language, the Groovy specific framework. It does remove a lot of boilerplate code. It also provides a cleaner and more readable DAO implementation. One more cool part here is that it works with Grails, Micronaut, or Spring Boot, and it also supports multiple languages for Java and Groovy. However, on the improvement side, only 3 to 4 of the most popular NoSQL databases are supported out of the box, and others require more effort or will not work yet. That would be all for our GORM conclusions. Let's finish our conclusions the way we finished our demos as well, with Spring Data. What about our conclusions for Spring Data? As you can have seen also in the controller, I fell in love from the very first time I came across the no controller configuration. It removes a lot of boilerplate code and again provides a cleaner and more readable DAO implementation. One more point on the positive side is that its loosely coupled code makes again switching between different NoSQL vendors just a matter of logistics. However, again, only a few popular NoSQL databases are supported out of the box at this moment. Yeah, Hibernate, just guess. Can you guess it? I bet you can. We are talking, unfortunately, about an outdated framework. There has been no release since 2018. Also, using a mapper for all scenarios is not a recommended approach. One more improvement, or one more point on the more not so positive side, is that some JPA concepts are not easily mapped to the NoSQL world. Example here could be the transactions concept. And last but not least, there is no error-safe way to run the query language and hydrate your DTOs on the result. That brings us more or less to the end of this presentation with a couple of links to the GitHub repository at the top, where you can find all the examples we showed today. and of course a project page for the JNoSQL project, which is still a work in progress. Again, we talked and touched upon open source software, so feel free to have a look at both repositories and even contribute. Why not, right? A few credits to flaticon.com, to Michael Simmons, and to Jean Touchet. I hope I pronounced it well. And I guess at this point, it is the moment I will have to say thank you for your attention. Werner,